Hello, and welcome back to another LeetCode problem. This one is the rotate list problem, and it's just like the rotate array problem, except this one is using a linked list instead of an array. Um, so we'll be messing with some pointers, and it'll just be a little bit different. So the first thing we're gonna do is we're gonna make a variable to hold on to the current node that we're looking at. And we're going to start that off looking at the head, right? So we're given a list node head, and that is the first node in the list, right? And to keep track of these nodes, we're going to make a stack. So we're going to traverse it, and then we're going to push all of these onto the stack so that we can, so that depending on how many we're going to shift off, we can make the proper adjustments to the list. So we are going to first find the end of the list. So we're going to go while current stack. We're going to add the current node to the stack, and then we're going to say current is current.next. So this is going to repeat until current is a null value. So that means we're at the end of the list, right? Current.next. So first current.next is going to be this node, and then we're going to move current over here, and current.next is going to be this node, then we're going to move current over here, and current.next is going to be this node. And so right now, what we're looking at is we're building a stack with the list. So I wanted to illustrate this. So this is the nodes, right? We'll just do it with a short 3-element list, right? And then this node, node 3, is going to go to a null, a null, or a none value, right? In Python, we call that a none value. So as we're going through this, first we have current pointing to this, pointing to 1, current points here, and then I'll say current, and then current is current.next. So current is this one. So in this next is this one over here, but we're going to push these onto a stack. So we have our stack here, right? And we put 1 here in the stack, as that's going to be the first value in the stack. Now this is not actually a copy of it. It's going to be pointing to literally the same node. So really, it's, you know, that's not a copy. That's literally the same node. But just to illustrate, we'll have this in the stack. There we go. And then we have 3. So then we have these in the stack. So depending, now we're going to have a k value. Say we wanted to shift k 2, right? What we need to do is and we still have our head is pointing to this node, right? 1. So what we're going to need to do is we're going to pop 3 off the stack, and we're going to say 3 next. We're going to point to here, right? 1. And then what we're going to do is we've popped 3 off the stack, right? What we need to do is we need to set 2.next equal to none. So basically we'll remove that, and it will be pointing to the none value now. And we need to make head. Now head needs to point to 3, right? So let's implement that. So we've gone to the end of the list, right? Once current is null, we break out of the loop, and current will be pointing to the last element in the loop, and we will have put all of our nodes on the stack, right? So what is it? Here it says that k can be it can shift anywhere up to 2 times 10 to the 9th, right? So a full rotation is going to be like the full length of the stack. So we want to use the modulo operator again, like we did in rotate array, to make k now the remainder of k divided by the length of the stack. So k equals k modulo and then so we're going to say while k, so we'll repeat this code as long as k is not 0. Once it's 0, we'll break out of the loop. So we'll just decrement until it's 0 to count how many times we're shifting over to the right. So what we're going to do is we're going to go current is stack.pop, and then we need to make current.next the old head, right? Current.next. So for the first time, we'll be making, like, for example, here the 5 point to the 1, right? And then we need to move the head. So now the head is pointing to current. So now our new head of the list is 5. But now we have this stack, right? We have this stack, and then the 4 is on the top of the stack, right? So, and the 4 is still pointing to the 5. So right now we have an infinite, we have a cycle in our linked list. The list is just a circle, right? Because that 4 is still pointing to the 5. So what we have to do is we have to say if there's still elements on the stack. What we have to do is we're going to have to say the last element on the stack, we're going to have that point to none instead of pointing to what we just made the head, right? So now the element on the top of the stack is not pointing to the head, but the one that we just popped off is the new head, right? And then we will decrement k minus equals 1. And so we will do this as many times as we need to rotate. And then finally, what we have to do is return the new head of the list. All right. So now let's give that a shot. Current equals. All right, so I figured out the issue was we were accidentally in C++, and this is in Python 3, so we will just paste that code into here, and now let's give it a shot. Integer modulo by 0. Oh, I forgot to say if, yeah, I'm sorry. There's one line I forgot. If the stack is empty, then we just need to return. And there we go. Thank you all for watching. I'll see you next time.